And yeah, now we can able to go for the flow. Let's consider Twitter classification. So first, I'll just go for a sample data. Let's go for a hashtag. Yeah, and they will be usually talking about some user. And this is a positive tweet. So this will be the whole sentence. Like this will be the whole tweet. And the output will be, let's consider as positive. Similar to this, we'll be having a -1. Let's have that one also.
So what you're doing now is you're creating things that will train the model, or what is this called?
This is sample input data.
Sample input.
Yeah.
Okay.
Like this, you will be having so many samples. You can also
Mm.
directly fetch the data from Twitter also using some APIs.
Yeah. Yeah, APIs I'm familiar with.
Yeah. Okay. So it will be in a table. This this will be a input and this will be the output. This is negative. So we have only two classes. So this will be binary classification. If you have more than two classes, means it will be multi classification. So the first thing is we need to remove all these hashtags, and we also need to remove some of these at users. What we actually do is we'll be creating some functions in Python to remove all these things in a single go.
Yeah.
So I already mentioned like normalization, tokenization, etc.
Yeah.
You will be doing this here. Maybe sometimes they will also use some symbols like this, exclamatory, question marks, like that. It can be any chunk.
Yes.
You will be also
Yes.
removing all these things.
Yes.
Maybe after cleaning, let's call it as clean function. You'll be using all the pre-processing techniques here. And after that, the result will be having only this. So it will be also in the form of table only. I'm just writing it as a single line. So what you have is a clean tweet. I don't have any numbers. It don't have any hashtags or users. So this is like an actual sentence you need to give to the model. So after this, you will be using tokenization. By using tokenization, you will be actually splitting the words into a meaningful way. So what it actually does is, so it will give you like this. And you can also convert this directly into numbers. Like this will be 1, this will be 2, A will be 3. Like this, you can build your own vocabulary, or you can use this bag of words and TF IDF directly to the whole sentence. So it will automatically do this process for you.
Okay.
So after this, you will be doing the feature extraction, bag of words, TF IDF. You will be using. In this, you will be mentioning those stop words. Stop words will be, if it's English language, means you will be specifying English. And the next one will be n-grams. So based on the n-grams, it will create your futures for you. So if you set by default, it will be 1. You can able to change the n-grams if you want. And other metrics also will be there. You can able to see what are the metrics in proper documentation. By using this feature extraction technique itself, you can able to increase some accuracy. in a practical scenario, I just change this n-grams from 1 to 3. Even it takes some higher amount of time, but the result is also somewhat better than the previous one. It will give
How
some.
do you know that?
Yeah, I will be testing the model.
Oh, but okay.
Yeah. Yeah. After converting this features, the table will look like this. Let's say this input and output. This will be some vectors or numbers. Even TF-IDF will give you some vectors only.
Mm.
And output will be positive and negative. It will be
Mm-hmm.
like this, but I already mentioned machine can only understand numbers, right?
Mm.
So what
Mm.
we'll be doing is there is a term called label encoder.
Right.
So what it actually does is it will just convert this string into an integer. So let's say positive equals 0,
Into a what?
negative equals 1.
Okay. Yeah.
So it will just replace this with this.
Yeah.
And if you want to get back these numbers into actual words for the result, means if you want to submit it to some contest or if you want to use it for some result purposes, means you can use inverse transform function. So it will be available in the label encoder itself.
Inverse. What do you call it?
Inverse means
Inverse.
it will inverse the whole process. So 0 will be converted to positive.
Right. Right.
So that is the objective.
Well, yeah. Are you coming back to that, or because you call it inverse
No,
transformer?
inverse is like at the end of the result when the
Yeah.
model is
Exactly.
predicting,
Yeah.
right? So you don't know what 0 means. You need to get an
No.
actual
Sure.
word. For that, you will be using inverse transform.
Yeah.
And apart from this label encoding, you'll be having so many encoding techniques. I'm just going for the most used one.
Yeah.
So that will be one hot encoding.
But by the way, this is could we write this in the code, or what exactly are you doing now?
Which one?
This. Are you writing it in Python?
Yeah, everything will be in Python.
Yeah, is this Python right now?
No, I'm just
No, you're
giving
just
you the
setting it
model
up.
names.
Yeah,
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 this will be the
yeah,
name, and this is also
yeah,
another name.
yeah.
So in one hot encoding, it will create a matrix-like structure. So let's say we have two classes, right? So positive is one class, and negative
Yes.
will be another class.
Yes.
So if you have a input like this, and the
Yeah.
output is positive, right? So you will
Yes.
be having 1. And negative will be 0. Whichever is mentioning in that particular row, it will be activated. So 1 represents this one belongs to this class. 0 represents it's not belonging to this class. If you say another one, let's consider. Let's say the next row is negative. So it will be like, so negative is the one, right? So one determines the class. It actually creates two separate column for two classes. So if you have n classes, means it will create n columns.
Could you? Yeah, I'm not following you because it's.
Okay, I will add another class. Maybe you can able to understand. Let's say neutral. Okay, now we have 3 classes. So the one hot encoding has created 3 columns.
Yes.
In the first sample, we have positive as output.
Yes. Okay. Okay.
So the positive will be enabled.
Right.
In the
But what
second
about
one,
the label encoder?
label
Because it says
encoder,
0.
it will just create a single column it will just change this only. If you go for neutral here, it'll just assign some numbers.
Okay. Okay.
So this is 0 or 1. So if
I
it's present,
understand.
it will be 1. If it's not,
Yeah.
it's 0.
Okay.
Even this also provides some additional performance improvement,
Yeah.
but it also has a drawback. If you increase the number of columns, the training time will be increased. But this is for output, so you don't need to worry. For input, you have some categories, like let's consider gender, male and female is there. And let's consider hours. There are 24 hours are there, right?
Yeah.
So if you convert 24 hours into 1 hot encoding, it will create 24 columns. If you convert that into label encoding, means it will just create a single column, but it will be having numbers, but machines understand better in binarical format. Okay. Yeah. After maybe for this example, we will go with this 1 hot encoding itself.
Mm-hmm.
Now it will be 0, and this will be 1. So we have defined our input and output. So these are the pre-processed ones. And after that, we'll be splitting some data.
Mm-hmm.
This is also a function in Python, so you don't need to do it
Just a quick
manually.
question. Why is the vector 0 and 1?
This is like an input sample. It will just give some numbers in actual representation.
Mm-hmm.
So this is the class I have converted. So this is positive, right? So I just converted
Yes.
it to 0. This is
Yes.
negative. I just converted it to 1.
Yeah. Could you go up 2 lines again? Just to line 95.
Which one?
Okay. Okay. Yeah. No. No. Now I understand. Okay.
Yeah. Now for train test split, let's say you have around 10K samples in total.
Mm-hmm.
You need to validate the model, right? You need to know
Mm-hmm.
whether the model is working properly or not.
Mm-hmm.
So for that only, you will be splitting this data. Let's consider train data as 75% and test data will be 25%.
Mm-hmm.
Now we are splitting the data 75% for training and 25% for testing.
Yes.
So while training the model, you will just pass this 75% data. So for predicting the model, like in order to validate the model, you will predict using this test data. So this data won't be trained with the model. So it will be considered as a real-time data also.
Mm.
So based on this, we will be able to get some accuracy.
Yeah.
So
So
if the
are you?
accuracy is lesser, means you need to train it again with some different models, or you need to improve the model in some other way. You need to do some
uh,
pre-processing techniques like that only.
If
So
the accuracy is less than what?
if the accuracy is so much less, means you need to do some additional pre-processing steps, or you may done overdo in pre-processing, or you need to change the model like that. You will be
Yeah.
getting
But
some terms,
how
right?
do you know if the accuracy is high or not?
There are so many different models for classification.
Right.
Let's
It,
consider
it, it
10
will be
models.
maybe easier if we look at some of maybe the code at the same time.
Which one?
If we, because I assume the model is finished now, correct?
Yeah, model training is done. You are just
Yeah.
testing with the remaining 25% of data. Based
Yeah.
on this 25% of data, how many things are you are correctly predicted using the model? That will be in terms of accuracy. So
Yes.
after splitting this, you will be training with the model train, and the model dot predict test.
Yeah.
And after that, you will just score the result using accuracy. So if you have some, usually in while using machine learning, you will get around 70 to 80 if you use machine learning models. that is like a best one if you consider NLP. If you go for some image processing or some statistical data, it obviously go up to 95 to 99. It depends on the data set. But for NLP, this is like a reasonable amount. Like I already mentioned, we have more than 10 models, 10 different models. So you will be training with all the models and come up with accuracy data. Based on this, you can able to find the top 3 models.
Mm-hmm.
So
just to be clear, when you say model, it's the type of
algorithm.
Yeah, exactly. You said it. Yeah, the type of models you're training with. Exactly.
Yeah.
Okay.
Now, after getting this, you will be remaining with 3 models with decent accuracy.
Right.
So now you want to try to improve some more performance of the model. Let's say this accuracy percentage is around 78. Okay,
yeah.
All the models are in the range of
just
70.
Just before, just a stupid question before we continue.
Yeah.
Right? What's the criteria for the accuracy?
Criteria means?
How do you determine if it's accurate or not? What lead it to be 75? What is, yeah.
Okay, maybe I will just go for this. We know the output of test samples, right? So I'll just consider it as Y test. So while calculating accuracy, you will be using the actual value. Maybe we'll consider this as actual value and the predicted value. So this one is the actual one. This one is predicted by the model. If both the things are same means we'll be getting 100% accuracy.
Right.
So if some samples are mismatched means the accuracy will reduce according to that.
Okay, so it's the amount of samples that will determine. So if it's too many samples, it indicates the model is doing some duplication. Is that correct?
Let's consider like 100 samples. It will be easier. For 100 samples, 80 samples are correctly predicted.
Yeah.
So 20 is mismatch means 80% is the accuracy.
Yes. Okay, I understand.
Okay. Now
so
we
you
have
want to get as close to 75 as possible.
I'm just going with the scenario. I don't know whether the actual models will come around this much. It depends.
I understand. Okay.
Yeah. Now we have got around this much. We want to push the accuracy further. Next, what we are doing is hyperparameter tuning. These are some machine learning concepts, but it will be useful in every scenario. So this will actually improve the accuracy, maybe 1 to 2%. It may seem less, but if you apply all the techniques gradually means it will come up with a larger accuracy. So that is the objective.
So could you repeat what hyperparameter was?
Yeah, hyperparameters nothing but the algorithm parameters. So if you consider as a model, it will be having multiple parameters. So the model parameters is displayed in the documentation. You can see what all the parameters are there and what all the values can be given to that parameter. So you will just by intuition, most of the people, if you have some experience means by intuition itself, you will just manually pick out some values and put it in the hyper parameters. Usually, I already said we are training with 10 different models means it already has some hyperparameters, but it is default values.
Yes.
So by this, we are just changing. So if you change the model hyperparameters based on the data set, it will produce higher metrics results.
Sure.
So here also, if you don't know what is the actual value, you want to find out automatically by the model means, you'll be having two common techniques, that is grid search and random search.
Could you repeat when you were using this again? You said something before grid search.
No, I didn't say about grid search. This is
Okay.
for hyperparameter tuning. If you want to figure out the values automatically, means let's say first parameters has two values, two possible
Yeah.
values, and second parameters has three, like that. Yeah, the values can range. So what grid search does is it'll just get all the configurations, like all the combinations. So it will use one parameter here and it will change the parameter here, and it will keep the parameter here and it will again change the parameter. So it will does is for all the iterations. In at some parameters, your model will actually improve, right? So it will actually capture that parameters in the end. That is the objective of grid search. It will use all the possible combinations that are available in the parameter list, and based on that, whichever parameters has the highest result, it will give out in the end.
Okay.
So it also has disadvantages because it's using all possible parameters. Let's say if you are going for, let's say if the model has 10 parameters and the possible values are also 10. So
Yeah.
that will take so much time. And also
Yeah.
model
Exactly.
training also will take some time. So usually it will take around 1 or 2 days itself for this grid search. Usually in contest only, they will be using this kind of parameter tuning in order to improve the score. But in real-time scenarios, it will be somewhat tedious without a powerful machine. If you have multiple cores of CPU, you can able to run it quickly, but it will definitely take some time. So in order to
Right.
avoid that,
Just a quick question about that. Is it a normal practice to use virtual machine for this type of work?
yeah, you can use some cloud environments for free.
But what's normal? If there is such thing like normal way of doing this?
If you have some small amount of data, means you can actually train it with your system itself with a normal CPU. But
Yeah.
usually it can be more powerful if you have some i5 to i9 processors with a good GPU, means you can able to train some deep learning models like smaller networks. Apart
Yeah.
from that, you can able to go for this cloud environment. One will be Google Colab.
Yeah.
It also has some GPU facilities and multiple cores.
Mhm.
And the other one is Kaggle.
Yes. Okay.
So people mostly prefer Google Colab because if you have a GPL, means you will automatically get access to it. So that's a part. And the second one is random search. So in grid search, the training time will be a huge disadvantage. In order to overcome that, we'll be going for random search. What it actually does is it won't go for all possible parameters. You will just specify some iterations here. Let's say I want to do around 100 iterations. In
Yeah.
100 iterations, it will just randomly assign the parameter values. So at some point, you may have some best parameters randomly that will improve your model. So that is the objective of random search.
Okay.
So it may find the best result or it may not. It depends based on the number of iterations. If you have more number of iterations, means you will be having more possibility. But in grid search, it obviously going to try all the possible combinations. If you just predict the model, means yeah, if the model accuracy is increased, and you can directly deploy this model to some cloud environment, or you can use it as a backend in a application also. So
But when you say when you create this NLP model, do you create it in a particular editor or anything like this, or is this just like a mind map basically?
yeah, we'll be using most of the time for creating this modules. The environment will be Anaconda. This has every package of machine learning and deep learning. If you want additional package means you can able to install it. And the second one is Jupyter Notebook. It is also
Yes.
come under Anaconda itself. So most of the machine learning engineers usually use this Jupyter Notebook because it
Yeah.
can actually stores the output also. Because next time if you want to see the results means you can just open the notebook without running anything. You can able to see all the results.
Mm-hmm.
And you can
Mm-hmm.
also execute the code block by block. So that is also another advantage. Apart from that, you can also create a whole Python file as a single file itself, and can also run using command prompt. That is also another way.
Yeah.
But I prefer Jupyter Notebook is
Ju-
far more better. Even if you go
Yeah.
for some blogs or any other things, Jupyter Notebooks is recommended one.
Right. So is it any beneficial to run Jupyter inside of VS Code, for instance?
No, VS Code is won't be running. Like it will be actually like a browser kind of thing. Yeah, you will
Yeah.
be
Yeah.
using a Chrome browser or Mozilla.
Hmm.
It will just actually a local website kind of thing, local server.
Right. Can you maybe show me the process of how this would work?
Which one?
How to create, like from scratch, how to create an NLP model? So or an algorithm, right? So you have now mapped out the model. What would be the next step now?
Yeah, after you have deployed some models, you will be getting some new real-time data from the user perspective, right?
Yeah, is it beneficial to look at machine learning before deep learning and from a understanding standpoint, or is
Yes,
it okay?
even for code purposes, for first you need to understand what is machine learning and all the stuff, and
Yeah.
it will be like on top of machine learning is a subcategory of deep learning.
What I would be interested in is what I talked about, being able to detect, like you have keywords and then you want to look at what's after those keywords, right?
Oh, okay,
So
that will be coming under recurrent neural network.
yeah, what about the sequence of the words
Yeah,
and detecting?
that is the RNN, recurrent neural
Yes.
network.
Yeah. Oh, okay. So, but what was this? I don't remember. If you go a little bit further up, a little bit more, n-gram, wasn't that something? Yeah, n-grams. Yeah. The n-gram when it was 3, for instance, isn't
Yeah,
that like a sequence?
yeah, that is like a shorter sequence.
Mm,
That's why we are using n-grams to get some more context information from the sentence.
yes, but I'm specifically asking, what are some really good use cases with machine learning?
I can't get you what your
So just on a general basis, for instance, sentiment analysis is a typical machine learning example, correct?
yeah.
And that's probably because it's a good way of applying machine learning.
Mhm.
What are
Okay,
some
apart
other,
from that,
yeah,
what else applications is there like that you are asking?
so that are good machine learning yeah, ways to apply machine learning?
Yeah, apart from that, for this NLP, we'll be using recommendation engine.
Yeah,
Um,
that's interesting. Recommendation engine.
Usually in recommendation engine, you won't be using this much of pre-processing. You will be using basic pre-processing, and after that, you will go for some similarity concepts like I've mentioned before.